Hi everyone, welcome to the channel. In this video, we're going to be looking at another worked example on differentiation. So let's get to it. So here we have an example. It's also a question from an old past paper. Given this function here, right, ln e plus y equals e to the power ln x plus y, we have to find the derivative dy dx where x is equal to 0 and y is equal to 0, right? So again, we need to find the derivative first before you can find what the expression is going to be where x is equal to 0 and y is equal to 0. Okay, now again, they don't tell you how to do this. So sometimes when you look at a question like this, you think to yourself, oh my word, what am I supposed to do here? But we look to the question for clues. So if you see they ask you for the first derivative, right? So this function here tells you, when they say dy dx, it tells you that y is your dependent variable, right? And x is your independent, right? Just by the notation that they use. And this, it might not be important really in first year, but when you get to your senior levels, they start changing the variables on you. So you have to know what is your dependent and what is your independent variable. Okay, but what it tells you is that when you find the derivative, you know what you're finding the derivative with respect to. So if you, for example, have an implicit differentiation, then you know whether or not there has to be a dy dx you have to put in or not. So if you look at the example we've got here, you see you've got an implicit function because of this here. Right? You see that y over there. That y itself is dependent on x because of what the derivative tells you. It says that y is dependent. So within that, you have your x value, right? So this is going to be implicit differentiation. Okay, so let's begin. Let me just write this over here. X plus y. Okay, now another thing about this is, if you look at the equation, you see we've got ln, our natural log, and we've got these e's, the exponents here as well. So usually when you see that in a question, you know that there are going to be some log rule somewhere along the line, right, or exponential rules. And at the get-go, you can see that that's the case, because what you've got on your right-hand side, you've got your base e, and in your power, you have your natural log. So remember that your natural log is log base e, right, of whatever expression this is going to be. So here, that exponent is going to be, let me just take this one out again. That exponent is going to look like this. It's going to be e if we write it out. Look, just so that I can explain the rule to you. It's going to look like that, right? Of course, we never write it as log base e like this, yeah? But what you can see now is that you have a base here of the exponent, which is the same as the base of the logarithm. And there's a rule for that, because if you have two bases that are the same, this simplifies into just that argument x plus y, which means that we have ln e plus y equals, and that is just going to be x plus y, like that. Okay. So now that you've simplified your function, and you've simplified it as far as you can go. So we are now going to find the derivative. So we take dy dx, which means that on your left-hand side, you're taking the derivative of ln e plus y, which means that the first function you're going to be dealing with is the ln, right? Which means it's going to be 1 over e plus y, right? The next part of the function is what is in the bracket here. And this is chain rule, right? So remember, with chain rule, you're looking at the different layers of the function, okay? So the first layer was the natural logarithm over here. The second layer is within this bracket. So then we say the derivative of e is going to be 0, because e to the power 1 is just a constant. So that's going to be 0 plus the derivative of y is going to be 1. Y itself is dependent on x, but you don't know what y is, right? So you say it is dy dx. That is the implicit differentiation part. Okay, then that is going to be equal to, the derivative of x plus y. The derivative of x is 1. The derivative of y, again, is 1. Y itself is dependent on x, so it's going to be dy dx, right? So that is the derivative over there. Okay, now what you want to find, we remember from the question, is you want to find dy dx. So you need to get all the dy dx on one side, right? So we can leave this as that, because I mean the 0 just falls away over there. And I'm going to take this derivative over, so I get dy dx equals 1. Okay. So now if I factorize, because I want dy dx on its own, I'm going to have 1 over e plus y minus 1 equals 1. Okay, so that's what I've got there, because I factorized dy dx. Right, so now I want dy dx on its own, right? But it's always easier to make these two terms into one term. Otherwise it becomes complicated when you have to multiply both sides or divide both sides by the bracket. So before I do that, I'm going to simplify it, just because it's easier to work with, over e plus y. Because remember, with your sums, you always want to make things easy for yourself. You don't want the calculations to become too complicated, because especially if you're doing tests or exams, then you lose values along the way. Your signs change for no reason, all because the sum becomes really big and clumsy. So try and keep it as simple as possible, if possible. So that numerator becomes 1. That is going to be e plus y. Okay, so then that means that dy dx is going to be 1 times e plus y over 1 minus e minus y, right? So that is the derivative dy dx. Now we're not finished yet. Let's have a look at what the question says. So once you find your derivative, you need to know what is that derivative going to be where x is equal to 0 and where y is equal to 0. So we've gotten to this part here. So now we substitute x equals to 0, y equals to 0. Obviously there is no x. So that means that dy dx is going to be, that's just going to be e over 1 minus e, right? And that would be your solution. Okay, well, I hope that was helpful to you. Let me know in the comments below if it was or if it wasn't, if you'd like something a little bit more complicated than that. And then I will see you next time with another worked example. Bye.